Hi, welcome to Data Marcos. My name is Dipesh, and in this video we're going to discuss end-to-end pipeline of Azure data engineering project. You might have seen different projects over YouTube, but this project is precisely made for beginner level participants, those who can deploy their project from very initial stage of creating pipelines and deploying by writing their code into Databricks and integrating with Azure Data Factory. Afterwards, you can even though integrate with Power BI. Let's get started in the project.
To start off, we'll look at the business request. It says in this project, your company has recognized the gap in understanding its customer demographics, specifically the gender distribution within the customer base and how it might influence product or purchases. So essentially, it's saying, we don't know if men or women are buying our products. With a significant amount of customer data stored in an on-prem SQL database, key stakeholders have requested a comprehensive KPI dashboard. They have lots of data, which you might be able to use to extrapolate male or female customers, and they want this on a dashboard, which is a KPI dashboard, key performance indicators. This dashboard should provide insights into sales by gender and product category, showing total products sold, total sales revenue, and a clear gender split among customers. Additionally, they need the ability to filter this data by product category and gender with a user-friendly interface for database queries. They have all this data on-prem, which just means in a computer they can access at that moment in time, and they want to create a dashboard using that data. They also want to be able to filter it. On dashboards like Power BI or Tableau, you can put up something like a visualization of sales, and then by gender, half of it will disappear. Then by product, another half will disappear, something like that. So, what is our solution going to be for that? Our solution overview to address this request. We'll build a robust data pipeline that extracts the on-prem data, loads it into Azure, and performs the necessary transformations to make the data more query-friendly. This transformed data will then feed into a custom-built report that meets all the specified requirements. This pipeline will be scheduled to run automatically every day, ensuring that stakeholders always have access to up-to-date and accurate data. In here, we're performing the necessary transformations to make the data more query-friendly, such as changing column names, updating data types, and even creating new tables if required. If you have a bunch of unstructured data, this specific tutorial uses structured data that is already cleaned and sorted. But if you had a business request with a specific set of tables, you'd need to understand the schema before and after and figure out the transformations automatically. The whole point of having a data pipeline is that it runs automatically. There's no point in having a pipeline that you have to run yourself all the time. Creating a pipeline is essentially creating a series of steps to get data, in this case, from one place to another. It's similar to DevOps pipelines, like code pipelines, where you're getting code from one place to another, and you try to automate that process to test it. So basically, we're just making a data pipeline that does some stuff and creates a dashboard. Now, this architecture is taken directly from Mr. K's video. I thought it's best practice to make it myself instead of just screenshotting it. Here, you can see we have an on-prem SQL database, and then an Azure Data Factory instance gets the data from that and ingests it. This is the ingestion process, and it ingests it into a data lake. In this instance, we're using an Azure Data Lake, and this instance we're using a specific type of architecture has a bronze, silver, and gold layer. Bronze is the raw data straight from the on-prem database. Silver has some minor transformations, such as data type changes, etc. Gold is where we try to change it to make it more query-friendly. You can imagine that bronze data is just the raw data as it is. Silver, in this instance, will involve changing some of the dates. For example, some dates may have seconds, but we want them all to be just day, month, year, or year, month, day, depending on the format you prefer. We don't need the time, just the date. Then, in the gold layer, we'll change the column names to make it easier when pulling the data into the Power BI dashboard. The column names will be clearer and more descriptive. To achieve this, we have Azure Databricks. Azure Databricks is a notebook platform on Azure that leverages distributed computing to scalably run queries and code against the data, moving it around. It's like Kubernetes with JIT notebooks, in a sense. We'll use Python for this. The next tool in the architecture is Azure Synapse Analytics. We use it to load the data. We get the data using Data Factory into the data lake, then transform it using Databricks. Once transformed, we need to load it into a structured format for querying with Power BI. Synapse helps us load the data in a way that's ready to be queried. Finally, Power BI is the destination where the data will be visualized for the end users. The part we are aiming to automate in this pipeline is this entire process, which we can run using daily triggers. At the end, we'll simply refresh the data in Power BI. We also have security and governance, which cover two main parts: Azure Active Directory, now known as Entra ID, and Key Vaults. For Data Factory to access the on-prem SQL database, it will need a username and password. We don't want to store these credentials in plain text, so we use Key Vault to securely store the password. Then, we grant Data Factory access to the Key Vault, which will automatically retrieve the credentials to access the database. Active Directory will be used to implement various security practices, which we'll explore one by one as we use them. At the end, we'll dive into Active Directory to better understand concepts like groups and RBAC, role-based access control. RBAC is an essential feature when working with the cloud. Instead of assigning permissions to individual users, you group people into roles and grant access to specific services based on that role. For example, if you're part of the data engineering team, you only need access to certain Azure services, like Data Factory and Databricks, excluding services like Power BI or Key Vault, depending on the team's role. Moreover, within those services, you might only have read access instead of write access. This helps ensure that each user or team has access to the tools and data they need without over-permissioning. We'll go over RBAC in detail later because it's more of an add-on feature for this specific course project. So let's start with this. And the easiest place to start is the beginning. So let's begin with the on-prem SQL database. To get started, the first thing we need is a dataset. For our on-prem database, we're going to use the AdventureWorks sample dataset provided by Microsoft. If we scroll down, it's essentially just sales data, customer data, that kind of thing, standard business data. We have a lightweight data warehouse, and all we're going to focus on is keeping it lightweight. We want a nice, simple database because the contents of the database and what we're really going to do don't matter that much. The point of this tutorial is more about learning the process of data engineering through pipelining. We'll download AdventureWorks LT 2022, which will download the file here. This file is essentially a database, and you'll need a SQL engine to run it. Here, I'll have all the links in the description. If we scroll down, you can see options for downloading SQL Server. We're going to want to use the Express Edition, which is a lightweight version of SQL. If you click that, it will take you here, where you can click Yes Basic and accept the terms. Then, follow the steps to download SQL Server. At the end, it will give you some values, but you don't need them for this tutorial, so don't worry about them. That's how you download the engine to run the database. But you also want to be able to interact with the database, and that's where SQL Server Management Studio, SSMS, comes in. SSMS allows you to configure, monitor, and administer instances of SQL servers and databases. We're going to use this as our front end to interact with the database. Again, there's a download link for SSMS. Once you click download, it's about half a gig, so it could take a minute or two depending on your connection. I'll cancel that because I already have it installed, but let me show you what will be installed. Once you open SSMS, you don't need to open the engine manually after installing it. It will already be running. If you go into SSMS, you can see the server type is DAT and the server name is SQL Express. This is the engine that we just downloaded. If you had multiple servers running, you could use them, but this is the only one we've got. Click Connect, and now we're connected. Now we have the engine running, the UI to interact with it, and the database, but it's kind of somewhere random in the downloads folder. We want to move that database to the backups folder within SQL. To do this, open a file explorer and navigate to the C drive, then to Program Files, Microsoft SQL Server. You'll find the MS SQL folder, and inside it, you'll see the backup folder. Simply drag and drop your database file into this folder. Now, the database is in the correct location within the SQL environment. Within SQL Server Management Studio, under Databases, you'll initially see nothing. Right-click, and you'll be tempted to create a new database, but you don't want to create a new one. Instead, we're going to restore the database from the file you just placed in the backup folder. Click Restore. Database, and then we'll click on Source, Device, go to the three dots to browse, click Add, and then here, if you're not in this location, we can navigate through or you can paste that in. So if you go into here, you could click there, then Control+C and paste that in to get here. Just click on LT22, click OK, and then it'll load up. There you go, we're set up successfully. Perfect. Now, you can see it, and it will appear here. If we open it up, we can see that there are a variety of tables within this database. Now, this is the part we're more concerned about. If we go in here, we can select top 1,000 rows, for instance. There you go, we can see the data. To do that, you just click on one of the tables, right-click, and select top 1,000 rows. From here, you can edit this query to do whatever it is that you want it to do. For example, you can modify it like this or change the column name. So, now we have the SQL on-prem server running. Next, we want Data Factory to interact with the SQL server. For that, we need to create a username and password, but we'll cover that in the ingestion part. For now, we're just setting everything up. So, if we go back to the architecture, we have it running. Now, let's go to Azure Data Factory, which is what we need. First, open up Microsoft Azure, which is portal.azure.com. You'll want to sign up. Once you've signed up, there's a great bonus they offer, and I'll show you by using a different email and password. I don't know my password for the spare account, but up here on the top right, you can see credits remaining. When you first sign up to Azure, it will show something like free trial $200 free credit for 60 days, or something similar. You get $200 credit, which is like $155. I'm in the UK. And for this, I've had it running for a couple of days using a variety of different services, and I've only used about $6 of that. The great thing is, you don't have to worry about it. You just get the free credit. Once you have Azure up and running and logged in, the next thing you want to do is create a resource group. You can see here it says resource group. If it doesn't appear for you, you can just search for it. Once you're in the resource group section, you'll see a list of groups, or you can create a new one. A resource group in Azure is a logical container that holds a variety of resources. The reason you want to use it is because it groups resources together logically. So, for instance, here we'll create a new resource group that will contain Data Factory, Data Lake, Databricks, Synapse, and Key Vault. This way, when we're done, we can delete the entire resource group, and everything within it will be deleted. It's a convenient feature in Azure because it saves you from having to deal with tags and other management complexities. Now click Create. The first thing that appears is the subscription. A subscription in Azure is like another container. It's one layer up from resource groups. It consolidates billing and provides a way to organize your resources. You'll have one subscription. Say for a dev environment, one for QA and one for prod, something like that. If you don't know what that is, it's essentially just different environments for development. So you'd have dev, which is where you do your development, QA or testing, where you test things, and prod, where you put them out into the world. That way, you can manipulate things differently and have different environments. For example, you could have an app you're developing, messing around with it, then testing it, and finally pushing it to production. These environments are always constantly moving, with things being shifted from one to another. We'll just name this resource group RG, and for the region, we'll select the closest to us, which is the UK South region, since that's recommended. Next, we won't need any tags, so we'll go ahead and review and create. It passes the validation, so we can create this resource group, and it will happen almost instantaneously because it's just a logical grouping. Let's go to the resource group and click to create it. Now, within this resource group, we want to create the resources. We're in the marketplace, and we can click Azure Services Only, which means we will only see Azure Services, not other things in the general marketplace. You should already see it, but if not, you can just search for Data Factory and it should show up. Click to create, then select Data Factory, which will open up a new page. On this page, we'll fill in the details: subscription, resource group, and instance name. We'll name it inch-dashed for Data Factory. For the region, we'll select the closest to us again and leave the version as is. Networking doesn't need any changes, and everything else should be good. Once ready, we can click to create it. You'll see the deployment in progress, and once completed, it takes you to a screen where you can see the subscription and resource group. From there, you can go to Resource and find the Data Factory. When we launch that, we'll have our Data Factory set up. Next, we need to create the Azure Data Lake. If we search for Data Lake, you'll notice that Data Lake Storage Gen 1 comes up, but we want to use the most recent version, which is Data Lake Storage Gen 2. If we select it, we'll be able to see that this is not a data lake as far as we can see, but what exactly is a data lake? A data lake is essentially a centralized depository designed to store, process, and secure large amounts of structured, semi-structured, and unstructured data. You can think of a data lake like a flowing body of water, where all types of data flow in, as opposed to a data warehouse, where structured data is kept in an organized manner. A storage account is a centralized place for all of your storage needs in Azure. It includes a variety of objects like containers, file shares, queues, and tables. So, when we click Create, we'll see that you can add all kinds of things such as containers, file shares, queues, and tables to store different types of data objects like blobs, files, and tables. Once we've created it, we'll select the same subscription, make sure it's in the same resource group, and proceed with the setup. Right, one for the storage account name. We'll just call it InSG. No dashes. UK South region is fine. That's all good. Next, here you may see the option for hierarchical namespace. This feature, complemented by Data Lake Storage Gen 2, enables file and directory semantics, accelerates big data analytics workloads, and provides access control lists. Checking this box essentially turns your storage account into one with data lake capabilities, meaning it will function as a data lake. After that, we'll just click Review and Create. We don't need to touch anything else, so let's move to the end and click Create. The deployment will begin. I was going to show you this earlier, but it was too fast. Once the deployment is in progress, you'll see the notification at the top. You can let that run in the background while we proceed with creating the next service. The next thing is an Azure Databricks instance. To create it, we'll search for Databricks and select it. You'll see it's deployed successfully, which is great. Now we'll go ahead and create an Azure Databricks workspace. Same setup: subscription, resource group, and workspace name. We'll call it InchD Databricks. After this, we can leave the rest as is, click Next, then Review and Create, and once validated, we'll click Create to deploy. Next, we'll return to the resource group where everything will show up. The next service we need is Azure Synapse Analytics. We'll click Create, search for Synapse Analytics, and select it. Once on the creation page, we'll follow the same steps: subscription, resource group, and workspace name. For the workspace name, we'll call it Inch Synapse. For the region, we'll select UK South again. You'll see that it prompts to select Data Lake Storage Gen 2. This is because, as you may recall from the diagram, Synapse loads data from the data lake to transform it into a more structured format, which is then used for running queries and creating reports. So here, we'll need to choose the account name for the storage and create a new one if necessary. This one is for the Synapse DFS for the file system. Click OK. Now, this file system is necessary because Synapse, as a workspace, has its own files it uses: logs, data, outputs, and things like that. So now you're saying within this data lake, you'll have your own little file system to use for your files and such as needed. I'll assign myself the storage blob data contributor role on the data lake to interactively query it in the workspace. Essentially, this gives permissions for Synapse to interact with the data lake. Next, go to the security settings, which are fine for now. These are worth consideration, but are outside the scope of this particular project. Click Review and Create, and it should deploy. It shows $5, but don't be alarmed. This is per terabyte, so you won't spend that much. If you're on a free trial, it won't cost anything. Now, back in the resource group, we have everything created. You might be wondering about the bronze, silver, and gold tiers. If you go into the storage account, on the left side, you'll see data storage containers, file shares, queues, and tables. Click on containers, and you'll see the file system has automatically created itself with a logs container. Now, we'll create containers for bronze, silver, and gold. Click Add Container at the top, then create bronze, silver, and gold containers, one by one. These containers are for organizing the data. So, for example, the architecture diagram will show that data will go into these containers. From there, data moves through the pipeline. Databricks mounts the data lake, transforms the data, and pushes it into the appropriate container. Next, we have AD and Key Vault. We'll come back to AD later, but for now, we'll proceed with creating the Key Vault. Go back to the resource group and click Create. Check the progress, and you'll see that the Synapse workspace is still being created. When it's done, you can go back and proceed to create the Key Vault. For the Key Vault, select the same subscription and resource group as usual. Here, you'll see that Synapse and Databricks both have their own systems. They require their own resource group, which they manage themselves. Just be aware that once everything is deleted from the resource group, the Databricks one may still linger, so you'll need to manually remove it. For the Key Vault name, we'll call it Ingestion, or something similar from the previous project, and we'll just finalize the creation. Here, we're going to go with UK South and standard pricing. That's fine. There's nothing more we need to do here. Just click Review and Create, and when it's done, the notification bell will go away, and then you can click Create. Now, back to the resource group. The deployment is still in progress. With that set up, let's move on to Power BI. To get Power BI working, you essentially need a Windows machine. You could do this on Linux or Mac by virtualizing a Windows machine, which means running a program that simulates a Windows environment. However, these services come with a cost. Some people have successfully used solutions like Parallels or UTM VirtualBox to run Windows in a virtual machine on non-Windows operating systems. Unfortunately, you can't do this in Azure or AWS because you'd need a Windows license key to run it. So, I'd suggest going with a Windows machine directly if possible. If not, there are two alternatives. One is using Tableau, which is similar to Power BI, or you can skip this part entirely. The dashboard is really just a way to show that you understand the full process and provides a tangible output for your work. It's nice to have, but for many engineers, the front-end stuff might not be their favorite part, so it's fine to leave it out. To get Power BI, you'll need a work or school account. If you don't have one, don't worry. There's a workaround. You can sign up for Power BI free for 1 month. If you don't have a work or school email, it can be frustrating because it prevents you from signing up, but you can still work around this. Go to Microsoft 365, and I'll add the link in the description. You can try it free for 1 month, choose the cheapest plan, and even if it auto-renews, Microsoft is good at refunding you. After confirming your email and mobile number, you'll get to a point where it asks you to create a work email. You can create something like look@something.microsoft.com. This will act as a work email, and you can cancel the trial immediately after. The work email stays active, and you can use it to sign up for Power BI. Once you have the work email, you can go ahead and download Power BI from Microsoft Online. However, the problem with downloading from the website is that it's a one-time installation and you won't get notified about updates. A better option is to use the Microsoft Store because it automatically alerts you when updates are available. The store works like a package manager, offering a user interface for updates, making it easier to manage. After installation, you'll have Power BI ready to go. Then once it's done, you can sign in, and it will bring you to a blank and old front cover bit, which says Create Report and other options. We'll show you when it loads up. There we go. This is kind of the splash screen for it. You can see here, I'm logged in with this email, doemicrosoft.com. That's it. So that is the entire setup to get each individual service running. In the next episode, we will cover Ingestion, where we will set up Azure Data Factory using Key Vault for security to get the information from the SQL database and put it into an Azure data lake. So the first thing we need to do, now that we have everything set up, is link the Data Factory to our on-prem SQL database. If we go to the Data Factory and launch the studio, this will essentially launch our workspace. I can show you that UI in a minute, but first, before we dive in, let's open SQL Server Management Studio and connect. That's all good. Something to be aware of here. If you've done the same as me, where you do one bit one day and come back the next, you can open SQL Server Configuration Manager. When we open that up here, my son's slipping next door. He's just a baby. We have SQL Server here, and you can see it's running. It can sometimes stop, and if it does, you can just click here to start the service. So we come back here, open our databases, and we have these. We'll go to AdventureWorks, open that up, and as we've seen before, the tables are available. We can click on one, right-click, select, and now we have a query for this table. What we're going to do is create a user. We'll create a user with a username and password, and we'll store that password into Key Vault. Then, Data Factory is going to use Key Vault to get the password and access this SQL database to pull the data up. Here, we have the create login query, which is create a login called look with this password 123455789. Then, create that user for the login. If we're clicked on the correct one here, we have the SQL open. We can click execute and that will run that query. It says look already exists. I must have created it yesterday. We'll call them looked and run execute. There we go. Command completed successfully. That will have created this login. Now, if we go back here to the portal, we have Data Factory at the top. Let's search for Key Vault. We'll open that up and we have our Key Vault in Tech Key Vault. Click in here, go to Objects, and then to Keys and Secrets. We want secrets because a key is like generating an actual key with all this good stuff. We want a secret, so we want to generate or import a secret. But if you notice, this isn't going to work. Let me show you. If we do a username as look2, we just get an instant error. Now, the operation is not allowed by RBAC, which is what we were talking about in the previous episode regarding role-based access control. Essentially, you want to create a role here that has the ability to create keys, and we want to assign that role to yourself. So, we'll go to IAM, Identity and Access Management, then Role Assignments. There we go. We can see this here, and I think this is lingering from a previous time when I've done this. So, if you click Add, then add a role. Assignment, and here we're going to just write in admin, and you can see Key Vault admin, so it lets you do stuff. Click on that, then we'll click Next. Now there's members, user, group, or service principal. We are a user. A managed identity would be like a service within Azure. So select members and then you pop up and you just select yourself. Click select. If you are in a company, there could be loads of users that come up, or there could be a variety of groups and service principals, but we have us with that there. Let's review and assign, and then that should be us straight away. Sometimes this kind of duplication thing occurs when it pops out. If you refresh up at the top, you'll see it will go away. So if we go back to Objects, Secrets, so the secret within our vault, you see that our RBAC error no longer exists. That's because we now have the capability to create secrets. So click Create, pop it in here, so we write username and then look to create. You see it's created that, and then the same again with the password Paul3456789. There we go. Apparently that password's been used before, which I'm not surprised about. So there we go. We now have access. We have made a password. So now let's jump back over to Azure Data Factory. Now from here, we want to create a new something. The main thing that pops up is you get a new pipeline, query, data flow, dataset. The one which we're concerned about is pipeline. So you can see here within Data Factory, you can ingest, orchestrate, transform, and configure some stuff. On the left, we've got this panel of icons. If we click Expand, you see Home, Author, Monitor, Manage, and Learning Center. So Author is where we can make the things which come up from new. So you see there are Pipeline, Query, Flow, Dataset, and Author. You've got that stuff there. We have a monitor part. You can run a pipeline, and that's where you can monitor the pipeline, trigger it, etc. There are other things like Manage, where you manage linked services, which is essentially a way to link services together so they have access to one another, and a variety of other things that aren't concerned with here. Then there's also the Learning Center, where you can get more tutorials if you want to go deeper into Data Factory. But for us, we'll go to Author, go to Pipeline, and we'll see there's nothing there. We'll click the plus, and you'll see Pipeline and then Pipeline. So this is what I was saying. You can create data sets, data flow, and other things. We want a pipeline from here. We'll rename this pipeline. We'll just call it copy data. So here within this pipeline, you'll see down the left, we have things called activities. These are just activities that the pipeline will do, things that it will do. And so you can see there's a variety of things like Power Query, machine learning jobs, iteration stuff like for each. And then if we come up, we can get to things like move and transform, copy data, data flow. There's a bunch of Azure functions, Data Explorer, Synapse notebooks, etc. Because quite a lot of this stuff like Data Factory and Synapse, I'm sure Synapse is built on top of Data Factory, but we'll come to that later. You can see that. Remove the one that's fine. So you see here, there's a one above source and one above sync, indicating that something needs to be done here. If we click on source, we can see there's an asterisk, which is saying a source dataset must be selected. Source is the source of your data. So for example, it could be a SQL database. That's the source. And the sync is where we want it to go, like a data lake. So we have to set these up. We'll click on new source dataset, and within here, you'll want to search for SQL or just SQL. You'll see down here SQL Server. The rest of them are a bunch of other things, different types of SQL servers, and then a bunch of Azure and Amazon ones. We are doing SQL since it's on-prem. Click Continue, and we name this SQL Server On-Prem. As I had just shown you and briefly talked about, we have linked services coming up now. So on linked service, we want to create a new linked service. This is what we'll use to connect to any other data source. We'll call it SQL Server On-Prem, and then just write linked service afterward. The next thing of note here is the description. Put in whatever you want if you want a description, but you don't particularly need one. Connect via integration runtime. We have here auto-resolve integration runtime. This is what we would select if we had services from Azure that we were connecting to, but we are actually connecting to an on-prem database, not one that's already in Azure. So you have to create a different integration runtime. You can see here what the network environment is. It's Azure itself, self-hosted link. For our example here, we're doing self-hosted. So if we click that, because as you can see, it's on-prem, click Continue. Now it asks, what do you want to name it? We'll name it Self-Hosted Integration Runtime. Click Create, and now this pops up saying how we're going to set it up. Normally, when it has that auto-resolve, they just link to each other. Here, I'm saying, right, I want to link somewhere. It's like, right, you need to now install something on your computer so I can recognize where you are, essentially. We have Express or manual. In our instance, we just do Express. Click here to launch the Express setup for the computer. It will download the program. If we open this up and go to Downloads, double-click and run this. When that's done, which can take a good 5 minutes depending on your internet connection, click Apply, and there we go. You'll see the big green tick there. If you're wondering, mine had an error because I already had this installed and had to uninstall it, which again takes ages. Version recommended is fine. Now, we want to fill in the server name and database name details. Come here to SSMS. Up at the top, you'll see desktop, blah, blah, blah. If we go to properties, you'll see the name there. You can copy that. So that's the server name. Then if we go back to the portal, paste that as the server name. Name. If we go back again to SSMS, where am I going? The database name is AdventureWorks LT 2022. So if we click on that, then click again, we can press Ctrl+C to get the name, paste that in here, and press Ctrl+V. We'll use SQL authentication, so it's the username and password we had just mentioned. For the username, we'll put in look2, and for the password, we could put in the password. However, we don't want it in plain text. We want to leverage the security features that Azure provides, so we click on Key Vault. Then, the AVK linked service. We have to create one here. So click New, and under Subscription, select Azure Vault as our vault system. Assign Managed Identity, which is fine, and it's a linked service. Click Create, and this will link the Key Vault service to the data factory. Now you'll see here that it doesn't load anything up. This is where the Active Directory stuff comes in. So, if we go back to our Key Vault, go back to IAM roles and assignments, and we want to refresh. We want to add a new role assignment. For this one, we want Vault User. So select Key Vault Secrets User and click Next. Here, we're going to use Managed Identity. If we click Select Members, we can then see the subscription is the same one as normal, Managed Identity for Synapse Data Factory, and a couple of other things. For this one, it's Data Factory. You can see our Data Factory pops up, so click on that and click Select. Basically, the link service is now set from the Data Factory's point of view, and we can go to get stuff from Key Vault. But now we have to go to Key Vault and say, by the way, this guy is coming, and this is his role. So click Select, then Review and Assign, and it will add that role assignment. When it does, you'll see it in here again, a duplicate, but refresh, and it should look good. If we can click the refresh button next to the secret name, you'll see the error goes away. Click the drop down, and the username and password will pop up. We can click on the password, leave it as the latest version, leave all the other settings as is, and click Create. There we go. The SQL Server on-prem linked service will be created when publishing. Now it's asking for the table name or what to join. We'll refresh that, and you can see it's not going to work. There you go. It says, can't connect to SQL database. To resolve this, let's go back to SSMS. We can close down the Properties window, then right-click the server that we're working on. Go to Properties, then Security. On this side, under Server Authentication, you'll see Windows and SQL Server, and Windows by default. You have to select SQL Server and Windows, so that this username and password can now work. Once we have that assigned, you might have to shut this down and open it back up for it to work. If we go back to the portal, Music. I've just realized I'm trying to debug my own tutorial and I can't find the table name. It's not working. It won't. Connect now. This is not connecting, and part of the issue is related to SSMS. You do have to make that change, but additionally, we can see it's just not working. It could be a database firewall. What it is it's trying to use HTTPS. If we go to Azure Key Vault again, I just tried with a password to see if that was the issue, if the password was wrong, because you can't see it, and Key Vault just tells you it exists as part of the security measures. But under Encrypt, you can see it says Mandatory. You want that to become optional. As you can see here, it indicates where TLS encryption is required, which is HTTPS. Now, if we click Save, or what we can actually do first is test the connection. This means we shouldn't get errors on the next page because of this. The connection is successful, which shows that it will work. Put it back to Mandatory and test the connection again. It fails, so that was the problem. Make it optional, test the connection, and save it. Now, we can see the table name doesn't have an error, but it doesn't have any tables. If we go back to SSMS, you can see there are a bunch of tables. The reason for this is that we have to grant look2 access to these tables. To do that, we'll just rewrite in here. Change this query to say, use AdventureWorks 2022. Go grant select on sales LT address to look to. Go. I'm not normally this bad at typing. I'm trying to be quiet because otherwise it makes a racket in the mic. Now, if we go to here and execute the command, it should be completed successfully. Once that's done, we'll go back to the portal, refresh the tables, and we should see sales LT address pop up. Click on that, click OK, and now the source has been selected. Next up, we want the sync, so where is it going to go? Obviously, we have within this data set the one we just created, but we don't want that. We want a new data set for the sync. For this, if we search for Data Lake, just search for Data Lake, and the Azure Data Lake Storage Gen 2 option will come up. Click on that, click Continue, and in here, we'll select Parquet, which is the column-based format optimized for querying. Then, click Continue, and we'll just leave it as Parquet. Next, we need to create a new linked service from the Data Factory to the Data Lake storage. So, we'll name it Linked Service at the end. Now, here we can do Auto Resolve Integration Runtime, since this is another service within Azure. For authentication type, we can leave it as is. Select the subscription and then select our storage account. Then, test the linked service and, once successful, click Create. Now you can see it's popped up. It asks for a file path, meaning where within that data lake do you want it to go. This is where enabling the hierarchical naming system comes in, which is what we've done to enable the storage account as a data lake. Click Browse, and here you can see everything within the containers of the data lake. We'll click Bronze because that's where I want it to go. Click OK, and now it's set to go to the Bronze container without any secondary directory. The file name can just be left as it is. Click OK, and now we can grab this. You'll see there are a couple of different buttons: Validate, Debug, and Add the trigger. We're going to debug first. This is basically saying if anything will go wrong with it, but it also automatically runs it. So you can see here it's queued and it's in progress. After about a minute or so, we can see that it has succeeded. Now, you can see there are a couple of different icons here. One is Details, which gives you some details surrounding it if you're interested, but we don't need to know that at the moment. Then, we have the two icons for Input and Output. If you click on Input, you can see what's coming into the pipeline activity, and Output shows what's coming out of it. This is particularly important if, for instance, we're going to do a for each. If this copy data activity was copying the names of tables, for instance, you could get it from this JSON object. But anyway, it says it's copied the data, so let's go to the storage account and have a look. We click on Storage Accounts, go to Tech and Data Storage Containers, then go to Bronze, and voila. Just like that, you now have Sales LT address in Parquet format. You can download it, though you won't be able to open it unless you have something that can open it. That's it for now. What we'll do next is delete this because we don't need it, but at least we now have proof of concept that we can get data from the SQL table or SQL database into Azure and into the data lake. So we delete it because the next stage is to update this so that it goes through every table, and then we can bring all the tables directly into that Bronze bucket. So what we're going to do next is create a new pipeline. That's easier for demonstration purposes instead of modifying the existing one. We'll name it Copy All Tables. We can delete the other one because it won't delete everything we made. It will just delete the pipeline itself. The first thing we need to do here is get a list of all the tables because we want to iteratively run the copy data activity for each table. So the first thing we do is create a lookup activity. This activity is going to look up, as the name suggests, in the source dataset. We're going to do SQL Server on premises, then click Open. Under Table, you can see a table is selected. We want to click Clear because we don't want any specific table selected. We want it to iterate through all of them. Now, back to here and use the query. We'll click query and uncheck first row only. Now, within this query, we're going to run a query that will get back all the tables within our database. The query is selecting the schema name and table name from the tables and schemas where the name is Sales LT. Why Sales LT? If we go back to SSMS, we see that Sales LT is the schema and address is the table name. For schema Sales LT, we have the address table and the product table. So what we can do now is click on that lookup and go to debug. After just 12 seconds, it succeeded, and we can see again the input and output. We don't really care about the input since it's successful. Looking at the output, we can see Sales LT address, the only table that's brought back. Why is it only bringing back one? If we go back to SSMS, we see that we've granted select access only on Sales LT address to the look-to user. If we change this to select and execute it, we can then grant select access on the entire Sales LT schema. This will give us access to all tables within that schema. Now, executing that grant, we go back to the lookup, debug again, and this time, after 13 seconds, we can see the output with 10 values: customer, customer address, and so on. This means we have access to all 10 tables in the schema. Now that we have the tables, let's copy them over. In the activities section, we can use the for each activity. Now we're going to drag that in, and you'll see a few options like